All right, so this is the final kind of tutorial video of the week. Probably the most, advanced question that we're going to see. We've got a cylinder with a triangle cutout through the entire length of the cylinder. Okay. So this problem is obviously going to require multiple steps, but let's just try to form a strategy. Okay. So if that triangle cutout wasn't there, we would have a full cylinder. Okay. And we've already done some examples where we find the volumes of cylinders. Right. But that cutout does exist, so we're going to have to calculate the amount of space that was cut out, the amount of volume that was cut out in that triangular prism. Right. So do my best to replicate that. Okay, so we're going to take the full volume of the cylinder minus the volume taken up by the triangular prism, and that difference should give us what we have there in that figure. All right, so the volume is the base area times the height. All right, so for the cylinder, the base is the shape of a circle. And so I can look at my original drawing here and I can see that the radius of that circular base is 10. So let's go ahead and write 10 there. The height is going to be 32 centimeters. All right. So because it's a circle on the base, we're going to use pi r squared to calculate that area. So pi r squared is the formula for the base area of a circle, and we're going to multiply that by height. All right, so that's going to be pi times 10 squared times 32. And let's go ahead and calculate this. Pi times 10 squared times 32. Okay, it's 10,053.09649. So I went ahead and wrote out all the digits on my calculator screen, just because I don't want to round too early and then lose accuracy, lose precision. Okay, so I'm just going to write as many digits as I can see. Okay. So that's the total volume of the cylinder, but then we have that triangle cutout. So let's figure out how much volume is taken up by that triangular cutout. Okay. So again, we're going to have to find the base area. And because it's a triangle, that'll be 1/2 length times width, or 1/2 base times height. And then multiply that base area by the height. All right, so let's see, the volume is the base area times the height. Now the height of the triangular cutout is 32 because it goes the whole length of the cylinder, so right, 32 there. We have some dimensions for the triangle, right? First, I don't know if you noticed this, but there's a tick mark here and a tick mark there. So those two sides are congruent, right? This is going to be an isosceles triangle. So this is 10 there, that's 10 there, and then we have the longer leg is 12 centimeters. Okay, so 10, 10, and 12. Okay. So that doesn't quite, you can't directly find the area just from those three measurements. We're gonna have to do a little bit of math here. So let's just draw this triangle. So that's 10, and that's 12. Yeah. Now, because it's isosceles, if we just drop an altitude like that, right, we know that's going to be a right angle. Okay. And it's also going to bisect this side. So if the total length was 12, then that's going to be 6 right there. Okay. So the question is, what is the vertical height, or how long is the altitude there? Well, since it's a right triangle, we can now apply Pythagoras Theorem. Right? So a squared plus b squared equals c squared. Let me just call that a. All right, so a squared plus 6 squared, since the bottom length is 6, equals 10 squared. So a squared plus 36 equals 100. So minus 36, you would get 64. Taking a square root, you would get 8. Okay, so the vertical height here is 8. Just carefully write that in, 8. Okay. So let me shade this in green so that you know that what we're looking at here, this triangle, is the bottom face of our prism. Right, so the area of a triangle is 1/2 length times width. You could also write base times height, but again, I don't want to confuse it with the vertical height of the prism, so I'll just use length and width, and then times height. Okay. So if we refer here, right, the length, the total length of our triangle is 12. The width is 8. And then the height is referring to the height of the prism, which is 32. Okay, let's zoom out just a little bit there. All right, so 1/2 times 12 times 8 times 32 gives us a total of 1,536. Okay, so that's how much volume is taken up by that triangular cutout. We're removing that from the volume of the cylinder. So we're now going to subtract these two values to get the volume of this solid here. So 10,053.09649 minus 1,536. Right, so the difference between those two numbers is 8,517.09649. Of course, Clever is probably going to say round to 2 decimal places, round to the hundreds place. So because that third digit is a 6, we're going to round the previous digit up. And so we get 8,517.10. And this is volume, and it's centimeters. So it's cubic centimeters. Okay. So I really enjoyed this problem. I hope you did too. I hope you understood the logic of it, right? Take the full volume of the solid, subtract the volume of the cutout. Okay, and so we're having to apply both areas of circles and areas of triangles to solve this problem.